Alright everybody, this is a video on how likely it is that you have COVID given a positive PCR COVID test. I'm taking a few numbers that I just grabbed quickly offline, so we're going to assume that all my numbers are correct here. But those numbers start with population and the number of cases both in the US and the world as a whole. I got the numbers for the number of cases from New York Times as of February 2022, and the number of cases are the trailing 6 months, so the last 6 months, how many cases have we had? And then populations were just found on Google and rounded. For U.S. population, I have it at about 329 million, and hopefully that's correct. I didn't bother to check. For U.S. cases, we have it set to about 78 million, and hopefully I did, yeah, 78 million. For global population, we have it about 7.8 billion, or just shy of 7.8 billion. And for the number of cases, 434 million. Next, we're having the actual test itself. So let me run this cell real quick. There we go. The next is the actual test for the PCR test, and we're checking both sensitivity and specificity. Sensitivity is telling you how likely are you to test positive if you actually have COVID. And then specificity is saying how likely are you to test negative if you don't have COVID. So it's kind of checking both sides of that. That was taken from cap.org, and you can find the full website right there. Again, we're going to assume these numbers are correct. I'm not going to go in too much detail on that. I just wanted to fulfill my curiosity here. So let's go ahead and run this. Just to show, PCR sensitivity was set at about 80%. So basically 80% of those who have the disease will test positive for it. And then for specificity, about 98%. So those who don't have the disease, about 98% will test negative. Then we need to actually compare what's the prevalence of the cases in the U.S., or the probability of COVID in the U.S. And so right here we have it set where we have the number of cases just divided by the total population, and that's for both USA and world. So we'll go ahead and run that. And real quick, we can just check it. So let's see, probability of COVID in the US. It's about 1 in 4, so about 23% there. And then for world, we have it set to world. It's only about just under 6%, so much less across the world compared to the US as a whole. My guess would be the difference is going to be just rural versus large city, something along those lines, or even possibly access to testing. Not really sure what that discrepancy might be, but it's a fairly big discrepancy there. So going with that, then we need to figure out how likely is it that you have the disease if you test positive. And we have this lovely formula here where the numerator is basically going to be the probability that you test positive given that you have the disease multiplied by the probability of the disease. The reason that you have to combine these two probabilities is because you could have a test, let's say that it's 99 out of 100 times they're going to test you positive for the disease, and you have very little error there, but maybe the disease is not very prevalent at all. Well, you'll have a lot of error or false positives strictly because of how unlikely it is that you actually have the disease. So you have to kind of compensate for that. And then in the denominator, you're going to have that same piece there, so identical to the numerator, and you're going to add in the likelihood that you test positive and you don't have the disease, again multiplied by the fact that, or the probability that that you wouldn't have the disease, or the prevalence of the not disease, if you will. Basically what you're doing with the denominator is allowing for all positive tests. So the top is saying here's the probability of a positive test and an actual accurate positive test, and the bottom is the total number of positive tests that there could be, essentially. We broke this up, so you basically have a numerator and a denominator, and here we're just plugging in these numbers. So PCR sensitivity is going to be this section right here. Probability of COVID in the USA is going to be that part right there. And then for the numerator, or sorry, for the denominator, we're just copying down the numerator for that, which is listed right there. Then here's the following section right here. So we're just going to break that up. and combine it back together here. So what this is showing is the likelihood in the USA, if you if you test positive, the likelihood that you have the disease is about 92%. So 9 out of 10. So pretty good. For the world, again, we're doing the exact same thing. We're just plugging in slightly different numbers here. It's going to be a little bit less, so about 7 out of 10. Again, the reason for that difference is strictly because in the world it's much less prevalent as a whole. And again, whatever reason that might be, whether it's lack of testing or whether it's truly less prevalent, I don't know, and I'm not going to comment on that. But given these numbers, assuming they're all correct, if you test positive for a PCR COVID test, in the US you have about a 92% chance that you actually have COVID. And if you're outside of the US, and again, that's very generic. I'm sure it varies from country to country, so you could be more specific based on the country. But it's about 7 out of 10. Anyway, I hope this was interesting. I was curious for myself, so I figured I'd go ahead and test it.